Alright, we've learned how to use the binom PDF function and the binom CDF function to calculate for the binomial. We're going to use the binom PDF only in cases where we're dealing with the probability of x is exactly one number. For all other cases, we're going to deal with some form of the binom CDF, the cumulative function. The basic version is when x is less than or equal to some value. So that's what I showed you in the previous example. Now, the other three possibilities is a strictly less than, a strictly greater than, or a greater than or equal to. In each of these cases, we're going to use a binom CDF function, but we're going to have to manipulate what we do. Strictly less than a value means that we look at every integer or every whole number directly below that value. So it's essentially the CDF of one number lower, which is why we take k and subtract 1 from it. Otherwise, these two are essentially the same. The next two, when we're dealing with greater than values, we're looking for the complement. We want the complement of a CDF specifically. So if x is greater than k, we want every number above k. So we want to reduce off of that every number k and below. So we just take the binom CDF up to and including k and do 1 minus that as our complement. Now, if we're looking for the probability of x is greater than or equal to some value, k, that means we want k involved, which means when we subtract off the CDF, we don't want k involved, so we drop it by 1. So our complements, and we drop it by 1. So here are going to be three different examples, all using the number 2. And this is the same example I used before. N is 4 and P is 0.6. So this one here, less than 2, strictly less than 2. That means we don't need 2, we only need the values of 1 and 0. So this is the same as saying the probability that x is less than or equal to 1, which is our CDF of 1, in which case k is 2, we look at the binom CDF of k minus 1. So to solve for that, second vars, I'm going to go up. The number of trials is 4. The probability of success is 0.6 again, but now the x value we're going to use is going to be 1 instead of 2. That'll give us these values alone. Paste it again, n, comma, p, comma, x, or k. So 0.1792. Alright, now if we're dealing with strictly greater than 2, we want the values of 3 and 4. So these are the only values we want right here. So we're going to subtract off everything else. The only way we can do that is with the CDF. So we're going to calculate this value here and do 1 minus it. So it's 1 minus the probability that x is less than or equal to 2. Or 1 minus the binom CDF where the k value is 2. So we can do it like this, 1 minus our binom CDF. N4, P.6, X2. That comes out to 0.4752. And our last possibility is if we're looking for a greater than or equal to. Greater than or equal to includes the number 2, so we want the values of 2, 3, and 4. So in order to find this area, since again the sum of all probabilities equals 1, we're going to use the complement and isolate this area. So it's going to be 1 minus the probability that x is less than or equal to 1. And now it's in a form where we can find the CDF of this. So finally 1 minus the binomial CDF, 4, comma 0.6, but this last one will be 1. And that equals 0.8208. And these are all the other three different possibilities that we have. So we've covered all of them. And again, with a small amount, you could certainly just calculate each individual one. If I could certainly just calculate these two and add them up, and that would come up to 0.4752. But if you're dealing with much, much larger distributions where n is 25 or 50 or 100 or more, the CDF function is very, very handy.